great to see everybody here after 2 years of lockdown and COVID. And it's nice to be able to get to see old friends and colleagues again.
Doesn't it?
If we all jump to the lifeboats, it's okay.
So, firstly,
We are working our way.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
Okay. Good afternoon. It's ready to go 2 p.m. So thank you very much for being here and giving me the ability to talk about smoke control in high-rise fire. My name is Michael REICK. I'm a fire chief from South Germany next to Stuttgart. I started as a civil engineer, worked at Research Institute for Fire Safety and Fire Testing. After that, I did my PhD about safety of anchors and connections between steel and concrete for the nuclear power industry. But my favorite hobby was always fighting fires, so I decided to go back to the fire service, had a 2 years career program, and since about 20 years I'm fire chief for 2,500 firefighters and for about 220 fire engines in my region. So therefore I'm speaking to you on one side as a firefighter, a fire chief, and on the other side the background of a fire safety engineer and some kind of researcher about smoke control in high-rise buildings. Well, we heard a lot about high-rise buildings the last few days, and there are not two similar high-rise buildings in the world, as buildings are totally different in shape, use, design and size, and even high-rise buildings are sometimes very individual, we have very high-rise buildings, ultra high, and also internationally from a point of view, compared from German high-rises to high-rise buildings in the US or in Australia or in other countries, we have different safety systems. And it's also a point in Germany, like we have legacy high-rise buildings where sprinkler systems are not mandatory. In the modern high-rise buildings we have these systems. We have ventilation systems in modern high-rise buildings, which makes it sometimes very easy for the fire service to work with them, to interfere with them, and we should have the knowledge to understand what these systems are doing, and we have the maintenance. This is all our built environment. We have to accept it as the fire service. We have to take these buildings as they are, and not all these buildings are in the shape how they would get an approval these days. And for me in Germany, it's a neat thing because all the building permits go to the fire service, and we have to give approval to all the buildings that are actually built. Therefore, we have the knowledge what fire safety engineers are doing, and if they want to do a fancy design and a fancy safety system, well, we look at these plans and think, how do we run our hoses in these buildings, and do our firefighting operations actually fit together with the plans of the fire safety engineers? And for me, therefore, this is something I just mentioned because I don't think it's the same all over the world. I have the feeling that fire services in other countries compared to Germany are not that much involved. And there is fire safety engineering on one side and the fire operation on the other side, and they should talk, I think, more to each other. In Germany, I think it's fairly fine because we are asked and have to give our firefighting fire service approval to all new buildings. And so we look at what we have, which is the expectation, what is the fire safety design and what is reality. And I think we heard it already today that during the lifespan of a building, some kinds of the features disappear. And to our observation, in office buildings, which are maintained by an agency, they are often still according to the code if it's quite a long time ago, but we observed, especially in residential buildings, that often somehow is something and somehow broken. We have to prepare for that. we have to accept it that it is there, but we shouldn't accept it that this is normal, because in residential buildings we often have a lot of people and a great hazard. People are sleeping, and if then the system is not there as it is, we have a problem. I also work for the German Firefighting Association as a person responsible for fire safety and the connection to operational firefighting. And we have some surveys there that fire is often contained in the apartment, in some kind of area where you have constructional components with fire resistance, but smoke is really nearly never contained. So our problem is the smoke spread in these buildings, and it's nice to have a fire in one apartment, but if the rest of the building is filled with smoke, that's the problem, and that's our workplace as the fire service. So we should expect this to happen. We should expect that even there are fireproofed doors, fire-sealed doors, smoke-resistant systems, but still the smoke is spreading, but we shouldn't accept it, but we should be prepared to do it. And we shouldn't use it as the fire service. I'm very critical about our own service also. We shouldn't say, well, this is an excuse for not being prepared to this situation. We know that these things happen, these things are our reality, and we have to deal and to cope, especially with smoke spread, and we as the fire service shouldn't contribute to smoke spread. This is something which I think is very important, and it's not always done, not around the world, and not always also in Germany. We tend to look at all the famous high-rise fires, and this is just a list a few weeks ago from Wikipedia for high-rise fires. You will find Grenfell there, you will find the fire in New York just in January this year there, and some others with also 46 casualties in Taiwan. So there are still high-rise fires not only in the Western world, also in the not that developed countries. So we have different fire services, different codes, and different fires. And for me, it was also interesting to look, for example, at this fire, which is not long ago in the Bronx in New York, just a few months ago. And it's nice to see that there's a fire on the third floor, second and third floor. The firefighting was in operation, and you see fire also way up the second and the third floor. You see fire escaping on these windows on the 10th floor, and this was a building with two staircases. Well, it was staircase A and staircase B, but it's a scissor stair construction, which saves space. It's a nice thing, but if not on every level, it's a clear naming which is stair A and which is stair B. And if the people don't know what's happening, and in this case, even if the fire service comes to a building when you have two staircases, but the tactic of the fire service, well, we take one stair to be the attack stair, and the other stair is the escape stair. It's an interesting topic. We would never allow in Germany to say, well, one stair is our stair, we'll take it as our use, and because it's our stair, it's the attack stair, and we allow smoke to enter this stair, and we open up a bulkhead door and actually transfer a stair into a chimney. This is something unbelievable for me, but this shows how we all are born and we all live in our tradition and in our tactics. And I'm here, I'm travel around the world to understand what people do in other countries. I'm trying to steal with my eyes and my brain what might fit into my environment, because we all have to realize we have different fire service, different built environments, different traditions, but some things are really interesting to really talk about them and to discuss them also in our environment. Like 5 minutes after the New York Fire Brigade arrived, they designed stair B to be the attack stair. You get the radio communication online, you'll find it. So the incident command center tells everybody who asks, dialing 911 there, how can I leave the building? Well, use, as an occupant, use stair A. But if people don't phone the command system, the incident command center, then they don't know it. And if you have a communication system, like they have normally in the US, you can use your radio and you can have the speaker in every apartment and tell people, this is the fire service, we have a fire in the building. If you want to leave, use stair A. But the problem is also here, if on level 10, one door from stair B, which you contaminate, is open, then you get the smoke all over floor 10, and all the apartments on level 10 are standing in a smoke-filled environment. So we have different systems all around the world. We have different tactics, and it's sometimes very interesting what goes on with it. And 17 people have been killed from smoke inhalation, 72 hurt, and 35 with life-threatening injuries. So it's not only about the people that die. It's also about the people that suffer a severe smoke inhalation, because sometimes they suffer for the rest of their lives. So therefore, it's often hard to judge and to do statistics with only the people that have been dying. The near losses, all the incidents where a lot of people had a lot of injuries are also, I think, very important for us to look at. Well, there are buildings that are well designed, that are buildings that are according to the code, and the first thing as the fire service, we should hope and expect for our plan A that the building is according to the code. In modern buildings, in very fancy buildings, we know that there are ventilation systems. Sometimes they try to get away of the smoke, extract systems. Sometimes you have pressurization systems. Well, there's a huge variety. I know a lot of them, and I checked a lot of these designs. Some are very nice designs, and some think, well, they are resistant. There can be one or two things, maybe not in 100% perfect mode, and they will still work. But sometimes I have the idea that if only one door is opened, if one thing doesn't work, it's not only that this system has a non-effect, sometimes I think it has even a negative effect. And so therefore, not of all these systems, I think, are really, they work in 5 or 10 years and in situation when there's already smoke inside of the building. They are very interesting, they are very focused, but the fire department doesn't know all this when they show up on the day of the fire. So sometimes you have the ability to be prepared before a fire, but often we come to buildings where we have no idea. And fire safety engineers, they look on their plans for weeks, and after a week everything is clear. You look at the building and you understand it. That's also for myself, if I have a plan and you work with the fire safety engineers, after a couple of days you know the building, you know the geometry, and you feel safe with the building. But you have to realize that sometimes in the night at 2 o'clock, one of your incident commanders will show up and he has no idea about the building. And he needs a strategy to go along within the building. And he needs not 20 different strategies. The fire safety or the fire service has to be trained in a very critical situation to act like they are trained. And I can't train 20 or 30 different tactics of fighting fires in high-rise buildings. I have to tell my people somehow to get water on the fire fast, to get people out, to orientate themselves in the building, and to don't negatively interfere with the safety system of the building, even if they don't understand it. And this is not that easy, because there is only one hose line. And only one single hose line can interfere with the whole building system. Like in this case, they stretched the hose line but didn't charge it with water. And what happens? The door closes, automatically closing door. And if now a person charged this hose line, we get into big trouble, because the fire service, they are ahead of this door, and you have water pressure on the other side, and you block this door. The firefighters are in maybe a burning apartment without water and with no chance to escape. So there are really a lot of dangerous things. If people never did firefighting, if they never stretched the hose line, they have no idea what can happen on an incident ground. And like, it's a basic problem that our hoses don't really get along very well with doors. And this is a fundamental point. And if I see fire safety designs where the water main is on one side and one door is very important for the whole design, if the door is not there, it's just a problem and the design doesn't work at all. And on the other side, we put a dry water main in the stair or somewhere, and you expect the fire service because it's meant for them to be used, and they stretch their first hose line, and then the whole design doesn't work anymore. Well, where's the connection between fire safety engineering on one side and the fire service on the other side? I think this is really a huge and common problem, and very often we talk to the engineers and say, well, it's everything fine, but we want to have this on another place. We want to have another door on this situation because we have to open this door. You assume us and you want us to open this door and keep it open, because if I don't open it 90 degrees and put it in place with a chalk, this might happen. So on a very practical point of view, we interfere with building safety design, and we have to talk to each other, the fire service to the engineers. Otherwise, everything is nice, but if only one door, if it's open, it doesn't work anymore, we really have a problem, and even the first attack team gets really into a dangerous situations. So when we talk about high-rise fires, some of us have experience with real high-rise fires, and they have a picture in their head about their last incident, maybe. So the last one I had is in the middle, what a high-rise fire I had last December in my hometown, but maybe someone from New York or someone from other countries, wherever around the world, they have their experience and they know what they think if they talk about high-rise fires. And in a lot of discussions, I often have the feeling that people discuss about different things, because it's sometimes an old building, a legacy building, sometimes it's a modern building with a fancy systems. There is a huge variety in all these things. And so we have to accept that we are all children of our environment. If you look in 80, 70 something, the first portable ladder was invented. And from this invention, maybe after some decades, you would assume that all around the world there are similar tools used. But just this as one example, the first portable ladder mounted on some wheels, and in France, in Paris, they have aerial trucks, but they are very famous in going up on the facade. They are trained on nearly a daily basis to use hook ladders. In Germany, they have been removed 30 years ago because we think they are too dangerous. In some other countries also. But the French, they train on them on a daily basis. And if you train hook ladders on a daily basis and you go into a stress situation, you get a tunnel vision and you do what you're trained to do. So just by their training and having hook ladders available, they'll use them. And they have multiple rescues of civilians using hook ladders. We have non-rescues with hook ladders because we don't have hook ladders. But what is my experience then? So my experience is influenced by the equipment I'm given, by the tactic I'm taught, by the training I received, by the members that fight the fires together with me. My firefighters are not healthy and fit enough and sporty enough to do this. In Paris, these are army soldiers. They are 20 to 30 years old on the job. They stay there on the fire department for a decade, and then they go in somewhere else. But these are really soldiers. And if you look at engines in the US or engines in Germany, they look quite different. We don't have the weight loading capacity on our roads and bridges for these heavy trucks. So maybe this is one point, but on the other side, we do quite a few things differently. But going back into a building, we discussed about getting people out or getting the fire extinguished also the last few days. And this is also a discussion in the fire service. All our tactical decisions that we make, we have people on one side which we want to rescue because they are in danger. If they stay in the burning building, they're going to die or suffer. And we have the fire on the other side. So we can decide basically, do we go for the problem? Do we kill the fire, extinguish the problem, everyone is safe? Or do we get the people out of the building and leave the fire just as it is? It might stay in the compartment, it might starve because it consumed all the combustible material, but it might also spread. And sometimes it can spread out of the window and on the facade, the sixth side of the box, very fast. Sometimes it can also spread interiorly But most of the time, even if it stays in the compartment, the smoke will spread interiorly through the rest of the building. This is something we have to accept. And by doing both tasks as a fire service, the rescue people or extinguish the fire, we interfere with air and smoke flows. Because we have to go interiorly into buildings, we have to open doors. We can't go, unfortunately, through closed doors already. It's not the task, and we are not trained as firefighters to do. So we have to open doors, and we have to decide if we, have a safe place concept, or we do some kind of fire ventilation, because as soon as we open doors, the fire gets additional air. The fire can communicate maybe with the stairway because we keep doors open. We change the flow path, we change the burning regime, and the fire will react to this. Normally we have under-ventilated fires in building, and as soon as we open door, we give it additional oxygen, and the fire can react to it. The fire will increase. If we keep the fire under-ventilated, it's sometimes nice because we have to fight smaller fires. But all goes together, it goes again together with hazardous areas, with safe attack and egress routes. And the question is, how do we protect our escape routes, our stairways? How do we control the flow of smoke in building? Because I think this is one of the key factors. And if you think about incidents that went wrong, it's because of smoke spread interiorly in the building. And you can basically bring all these things together to this point. And already Brent showed a movie out of this case. When they opened the door, the fire department in New York, you saw that in 4 or 5 seconds the hallway filled up with smoke. The fire service also opened the door on the other side of the floor. So in case something happens, they have a refuge area. So it's really an interesting case, but what you see basically is that in a few seconds, if you open a door, you will get a smoke-filled hallway, and if the door to the stair is open, also the smoke will spread into the stairway. Paris also goes interior, but as I already told you, they also like to go out from the outside, which is a nice point because you don't have to open doors in this case. But you have to go in and you have to go out and you have to get people out. So it's not a solution, like nothing is a solution for everything. We need a lot of tools in our toolbox as the fire service to be prepared for different situations. But we have to minimize the amount of situations we should prepare. So we have to learn lessons. Sometimes we learn lessons on an easy way and sometimes on a hard way. And the LFB, that's what I saw and how much I investigated also in this case. Since then, at least, invented or took smoke hoods into their operation. And also, this build is from Dublin. They use it since a couple of years. But also LFB now starts to try interiorly to block the spread of smoke, which I think is very important. We do this since more than 20 years in Germany. Because if you look at the German population, if you look at our fire safety systems, half of our population, nearly 40 million, lives in 1 or 2 family dwellings, and half of the people in Germany live in multi-family dwellings. From 3 up to more than 20 apartments. So we have a couple of million people living in multi-family dwellings, and for us this is always the normal situation. If we assume an interesting task, an interesting and dangerous fire for the fire service, it's always a fire in a multi-story apartment building. And the question now for us is, how do smoke spread into these buildings?
Tor Building Fire Safety Network delivers high-quality safety management training for anyone involved in the fire risk management of high-rise or tall buildings. Recognised by the Institution of Fire Engineers, we've been delivering fire safety training since 2011, and many organisations rely on our training for gaining competence in this field. Sign up for our training courses and conferences in 2023.
Well, start with a closed compartment. Well, sometimes people ask me, oh, well, we have a closed compartment, the door is closed, the window is closed, and you have a 10 megawatt fire in this apartment. And I say, well, that's nonsense. there is no 10 megawatt fire where I need 1,000 liters per minute to flow in a closed compartment. At least not in Germany, because our apartments have a size of maybe 70 to 100, 110 square meters. They have normally concrete slabs as slabs and masonry walls and gypsum surfaces. We don't have so heavy wood construction where you have all the surfaces are combustible wood. We're going to change into this direction, at least our politicians want to, but we will see how this will change our built environment, and maybe we have to see these changes ahead, because it's a different fight of fire, this one of these known unknowns, which we had already this week. So if you have a confined space, the fire can consume the oxygen, and if oxygen goes down to 15%, the fire already goes in the decay phase, depending on the temperature. So we know these fires, and most of the fires in buildings are underventilated fires. As long as you keep them underventilated, maybe if you can undervent them perfectly, they even get out without applying any water at all. Some fires do this, and we see that more and more fires in Germany with triple glass windows, with very good doors, entrance doors for noise reasons, to staircases, very good built apartments. You just keep the door and windows closed and the fire will extinguish itself. Well, it produces carbon monoxide, it still releases some smoke into the rest of the building, so yes, the fire service will still show up in open doors. But this is one kind of fire. But as soon as we have openings, like an open window to the outside, the fire will get rid of some smoke. Like an engine, it needs to get rid of its products of combustion, and it needs fresh air to burn in a steady state. And now every time you open a window or a door, the fire needs 30 to 60 seconds. We always say as an estimate a minute. So the fire can react to the change in the burning situation, and still it oftentimes is nearly in another steady state situation. And this is difficult for the fire service, because we don't open doors, wait a minute and say, well, now it might be a better ventilated fire, now we have another burning regime. So we open and interact with the building, not knowing what happens in the next minute, also with the flow path, with the burning regime, where do the products of combustion go, and how do the fire actually develop. And the most important point for me today, I have to focus on one point, is the entrance door. Like if you have a window, 1 square meter opening to the outside, one point, I'll come to this point later. The other thing is the entrance door. Well, we get fresh air flowing in low and smoke flowing out high out of an entrance door of an apartment. That's a normal observation. As long as you don't have heavy wind on one side, then the game can change. But this is how we contaminate, by opening the entrance door, stretching our first hose line, normally staircases. And this is a very interesting point, and about 20 years ago I did post-PhD studies for a couple of months, and my point was actually, how can we get rid of this stupid red arrow that is smoke going into the staircase? What can the fire service maybe do differently to avoid the spread of smoke interiorly in buildings? Because if you look at pictures all around the world, you see staircases filled with smoke, you see firefighters approaching interiorly, and the stairway for us tactically is the most important room in a building. If we are losing the staircase as a fire service, we have a 3-dimensional problem. And if the stairway is under control, we have a 2-dimensional problem. Sorry for some German expressions, but this is how we train our incident commanders. And if you have a 3-dimensional problem, you get rid of the 3rd dimension. It makes it much easier. You only have to deal and cope with one floor, and you have to solve the problem on this level. So why get it a 3rd dimension? And on the other side, like on the left picture, this was a 30-minute fire-rated door. It was there for 30 years. In 30 years, the people didn't like it, because always they come from their garage, wanted to go through with their groceries. They had to place them on the ground, open the door, but as soon as they grab their bags, the door is closed again. So normally you open it 90 degrees and open it, keep it open with a chalk. It's much easier for the daily life. But it was actually closed for 30 years, and then the fire service showed up, and the first thing is they opened it 90 degrees and put it open with a chalk, so they can stretch their hose line through it. So I think it's incredible. There are building components there that work for 30 years, and the first thing that the fire department does is get them out of control. And they don't do what they are meant to do. This is crazy. But we have a fundamental problem between closed doors and firefighting operations, at least when we have to go with our hose line through these doors. Therefore, these are all situations, and sometimes we see these situations when we arrive, and sometimes we contribute to these situations. And I showed you this picture already, a little bit bigger size, to show you the problem that we have with doors closing, because really, if you go ahead as a firefighter, and you ask for water, you to charge your hose line, and the door behind is closed, we have to chuck these doors open. Otherwise, it's a security problem for our people. They are in a fire situation without water, and their exit is blocked. And this happens. So there are a lot of dangerous things, and we have to address these in training. We have to tell our people how to advance in buildings in a secure way, also for our personal security. So all around the world, the fire service talks door control, but sometimes for different interests. Some talk about door control to have a safe entry. Some talk about door control because of keeping ventilation closed. Some about smoke spread. So a lot of different things. I don't want to go too deeply into these different philosophies or tactics, but you can do it on a couple of ways. There's even the possibility, number 6, that maybe all fire-resistant doors in the world should have a small integrated door for the hose of firefighters. And these doors are actually there. If you go to vessel firefighting on the ship, you can't go out abroad from a ship if there's a fire on sea. You have to stay in this compartment. So ship fire crews have to fight a fire, but not allowing the fire to grow, not giving it air, and not allow the smoke to spread. So in a ship, maybe on the docks, in the machinery area, you have maybe doors with integrated doors. And it's not for the cats in the ships, it's for the firefighting procedures. And on the other side, no one of us wanted to have an apartment door and all interior doors with such integrated doors indoors, but they would be helpful, they would be useful. And so firefighters do different things around the world. On the bottom right, this is what is done in Finland in training manuals. They tell people to take a motor saw to cut the lower part of the door away, keep the upper part of the door as a blade intact, and crawl in low. Well, if it works if it's a wooden door, and I ask them how often do you do it, because it's in their training manual. We do it in training, but we never do it in reality. So firefighting training has to do something with reality, but interesting concepts all around the world. There are a lot of discussions about ventilation profiles, because more and more fires are underventilated now. And if we give them additional air, also we might use positive pressure attack, so we actually use a portable fan as the fire service to really push fresh air into the fire compartment. And an underventilated fire that needs air, and you give him additional air, will grow. And on the other side, you might have then some hot part of a flow path, and you shouldn't have firefighters on the hot part of the flow path. And this is also something, in Germany we try to stabilize the situation. Compared to a car accident, if I show up as the fire service in a car accident, I protect myself against further traffic. I protect the car from lighting on fire, so I have a hose. I protect the car from falling into the water, so I take some rope and put it in place, and then I get the person out of the car. So I first have to stabilize the situation, and from this point I have to make it constantly better for everyone. But in building fires, I sometimes have the impression, and with some tactics used worldwide by the fire service, that first we allow the fire to increase, we allow the smoke to spread, and from this position we make it better. And this is also something we have to think about, that from the beginning of the arrival of the fire service, from this position, it should constantly only get better. It shouldn't get worse first. And so therefore all these burning regimes are an interesting discussion. I don't want to cope with it too deep now, but there are some discussions about bidirectional flow, about unidirectional flow of a higher strength. And the best thing would be to have a unidirectional flow as a fire service, but with a low volume flow, because this doesn't feed the fire. So how can we gonna achieve this? Well, 20 years ago nearly, I did a lot of calculations about this entrance area, about going from a bidirectional flow to an improved unidirectional flow, having fresh air flowing in low, because low is where the victims are, low is where I need the visibility. When I crawl in as a firefighter, I want to have a cold and good visibility environment low, and then I see the fire, I can use my hose line and I can fight the fire above me, I can cool the gases, I go inside and get water on the fire fast, because this is my target. And when I looked at it 20 years ago, I found these 11 parameters for multi-story residential buildings. The size of the fan, the geometry of the staircase, openings in the staircase like the bulkhead door, opening of the fire compartment to the outside, the fire size, wind number 11, and all of these parameters are nice, you can play with them, but what can you influence? You maybe can use a KO curtain on the outside so you can remove wind, but we don't have it. And in our environment, all the buildings have balconies. It doesn't fit to a balcony. So a KO blanket, which might be used and might be a good idea in the United States, I can't use it in my environment. But I realized the most important point, and the point where I always want to be and where I always am, is point number 5. Point number 5 has the most influence on the flow path, on the smoke spread, on the whole behavior of smoke spread and the fire behavior in the building. And this is the position where I always want to be as a firefighter, because this is the way people leave the building, and we want to find people that trying to leave but have been overcome by smoke, so we find them in staircases. We have to go into the staircase. It's the most important room. We have to secure it. And from the staircase, if we don't want to make it a 3-dimensional problem, we have to keep the stair door closed so that the smoke doesn't spread on this position. So actually from this interesting theoretical model, we try to convince ourselves that we need something to do it, to do it with a tool. And this is one of the first fires in 2006. You'll see the children's room on top left. Totally in fire. You see the corridor of this apartment, even gypsum was falling from the ceiling, so it was fairly hot. And on the right side, you'll see the entrance door to the apartment from the staircase. One of the first uses of portable smoke curtains documented in Germany in 2006. And we have, meanwhile, thousands of these pictures. It's well used since 15 years. It's a standard in Germany. And I could show you pictures from Munich since 2008. The Munich Fire Department has the rule, if they assume smoke or fire behind the door, they don't open it before they hang a curtain. It's not 100%, it's not a one-size-fits-all, it's not perfect. But it's a solution, or at least a method, to reduce 70, 80, 90% of the smoke flow into the building. Not always 100%, depending on wind, but in normal situations, most of the smoke can be kept in place. And what is also nice, you'll see normally if you open a door, 1 or 2 cubic meters of smoke being released. So the apartment is in an overpressure. If you see this, you know the apartment is closed. There was some kind of overpressure. Now I released 1 or 2 cubic meters of smoke, and now I can go in and fight an underventilated fire. If I get a constant flow inwards, I know there must be a window open. Now I'm feeding the fire with fresh air, so I better go in, get water on the fire, extinguish it. So there are a lot of interesting things you recognize as a firefighter as soon as you have the ability to really see. And it's absolutely obvious what happens at the entrance door when you open it in case of ingoing or outgoing fresh air or smoke flow. So very interesting and very good for firefighters to really actually see. We used it in hospitals, 2009, it was a hospital fire. And on the right side, you see the room which was on fire, interior room, no access to windows. So we used an ejection fan with a tube and got rid of the smoke by closing the entrance door. An insurance company realized that this saves them more than 100,000 euros in smoke damage per 1 single use. So if the fire department has no chance to get the smoke out of an interior room, they just can open doors, release it in the rest of the building, And in a hospital, if a lot of rooms are contaminated, they have to decontaminate, they have to close them down for weeks to clean them. They say, well, this a single use with the right tactic is a saving of 100,000. So insurance companies in Germany since 2008 and 2009 told the fire service, well, if you need these tools, we would like to pay for them and to improve them. And they actually paid for them. So in Germany, out of about 20,000 smoke curtains used, roughly, 7,000 have been paid by insurance companies. And if you apply 7,000 by 300 euros, it's a 2 million euro project. Oh, come on, this is a pay on a single incident what an insurance company does. So for them, this is nothing. But it tells the fire service that it is important to look about smoke spread, not only for damage reduction, we do it mainly to get people out, to prevent people from being affected by getting smoke inhalations. 2013 Berlin, 2014 Austria, Vienna, 2015 Hong Kong, a high-rise building, Paris, picture from 2020, a picture from my area, high-rise building, where you have two doors behind each other. The smoke curtain was used to keep the staircase smoke-free. So there are some, I think, very universal statements. So the experience of the fire service all around the world is limited to how they've always done it, the tools you'll give them, and how they trained, because how they train is how they fight fires. We always have to be aware about ourselves and our built environment. It's different, the buildings, the society, so solutions that might work in Germany might not work in Australia. But we all have to be open to see what others are doing and try to think about if they fit in our environment. We always have to distinguish in our strategy and our tactic between rescue and extinguishment. Do we have the ability to defend in place or full evacuation, or do we have to extinguish the fire first? And this is tactics, fire dynamics, skills, and smoke spread control. And to do smoke spread control, because it's essential, we have to know our environment. We have to accept that as a fire service we interfere with it. Nearly every action on the fire ground can lead to smoke spread, and smoke is actually what is killing people. We protect the stairs. Still, we try to get water on the fire fast, but we also have to rescue through smoke-filled areas. So in Germany, my 220 fire trucks, every one of them has 3 smoke hoods. But more and more, we also have the experience that in a smoke hood, you have to breathe through a filter. And for elderly people with COPD, not that healthy, a filter has still some flow resistance. So this is my REICK team on the bottom left. We have REICK teams in Germany, 2 people in, 2 out, normally everywhere around the world, but realized from investigating incidents that if a firefighter has trouble, another firefighter team can rescue him 20 meters horizontally, but not vertically. So as soon as we have to rescue someone vertically in the fire service, 2 people are not enough, we need 4. We did a lot of training, a lot of things, but if you really want to rescue one, you need 4. So I have teams in my county with a response time of 15 to 20 minutes, and these 4-person teams are there. If a fire attack team is in an area where there is no safe place on the same level, which can be a staircase, but if you're losing the staircase, if you don't care about your staircase and you allow it to fill with smoke, you have no safe area on the level. Then you have to have a 4-person attack team. And the 4-person attack team, they have double bottle, intended duration, EDBA, breathing apparatus, so they have a Y with them, and every one of them has a smoke hood which flows air. So you can give just member of the public 50 liters of oxygen per minute on a ventilated hood. This is much nicer for an elderly person who has a problem with breathing through filters, and these teams can go in buildings, go into an apartment, take a family out of 4 under 4 hoods, and walk down with them through the staircase. So this is not something which is a standard tool on our trucks, but this is something the built environment expects us as a fire service to do. We have to rescue people through smoke-filled staircases, because staircases sometimes somehow are smoke-filled. We have to accept it, even if it's not our standard procedure. And it's not fancy, it's not rocket science. It's just a small piece of tube and a wide cylinder on my breathing apparatus and a small hood that allows it to attach, and it flows 50 liters of air a minute, so someone can breathe. It divides by 2 my air volume, which I have available for myself. But therefore, these teams have 60-minute fire bottles. So we have to stabilize the situation. We have to protect egress routes, and using such an easy tool is something very easy, and it's a few minutes until you get it, and then you really learned it. Okay, so this was just an overview in a very rushed manner, and one example just a few months ago from our area. You might find some things interesting. Let me know. You might think that some things don't fit into your environment. Well, this is your judgment. But every one of us has to be open to look what is all around the world, done by colleagues, and look what might fit into our own environment. Thank you.